Hello everyone, in this tutorial I'm explaining about software interrupt instruction. So software instruction causes the ARM processor to call the operating system subroutine, so we know that. So whenever the software instruction is encountered in a main program, so it will going to force the ARM processor to change its mode to a supervisor mode. See, as you can see here, upon encountering the software interrupt, so first thing the ARM processor will do is it will going to switch to the supervisor mode. So while switching to a supervisor mode, it will copy all the contents of a CPR register to the SPSR. That means whatever the contents or the status of the processor, that will be stored inside the SPSR, and then it will make the I bit, that means the interrupt bit in the CPSR register, to 1, which will going to mask all the coming interrupt requests. So whenever the processor is executing a subroutine, it will going to ignore all the requests that will going to come from the peripherals. That's why we are just masking the interrupt, so that no interrupt will going to again interrupt the processor while executing the subroutine. So this is what it will going to look like. And one more thing is, it will going to load the address 08. Why? Because we know that, I'll show you while we studied about while we were studying about the exception, interrupts and vector table, we know that whenever the software instruction will encounter in a main program, it will force us to it will force the program counter to have the address 008 of the vector table. So we know that we have already studied about the vector table. So whenever the software interrupt will going to be encountered, the program counter will be loaded with the address 008, which is of a vector table address. Now let's come back. Sorry, I'll just okay. Now, so these are the first thing that will going to happen when the software interrupt will going to be encountered in my program. So upon entering into the SPSC mode, I have to call as I told, and sorry, I didn't told about the syntax. So in this general syntax, we're going to have like a opcode SWV SWI along with the SWI number. So this will going to specify which subroutine has to be executed by the system operating system. So how to calculate this SWI number? So we're going to have like this. The process will going to be have like this. Upon encountering this software instruction, so it will, whatever the thing I told you before, so it will jump into a SPSR. It will going to mask the interrupt request, and the address of the program counter, that means a program counter plus always it will going to point to the next instruction to be executed, right? So that address will be -4 will be loaded into an LR register, which means a link register. So link register will going to hold the address. So whenever it will going to come back from a supervisor mode to the user mode, it has to have an address where it has to exactly switch into and start executing the remaining part of the program. That's why we're going to hold that address into a link register, and it will going to force us the program counter to have this vector table address 08. So when I go to this 08 address in the vector table, it will again going to switch into and switch like a interrupt handler. It will going to switch into an interrupt handler, where I'm going to just mask the first 8 bits of the instruction. So when I mask the first 8 bits of the instruction, the opcode, whatever the opcode that I have written, that will be erased off. So masking means it's just to clear all the bits. So remaining 24 bit will going to give the address or the SWI number. So the processor in supervisor mode, the processor will going to jump to that location, and it will going to start executing that subroutine. So after completing the subroutine, it will going to come back by using a instruction called as a move a PC comma LR, like that. So whatever the link register holding the address before jumping into a supervisor mode, that will be copied to the PC, and again it will going to start with the same the next instruction that has to be executed in the main program. So now this is about the masking, and these are some of the examples. See, as you can see here, I'm just going to mask this I bit. so which will make the CPSR2 switch into a supervisor mode, and it will going to copy the LR register. So whatever the program counter is pointing to, so R14 is nothing but a program counter, that value will be copied to the LR register, and after switching to the supervisor mode, it will going to execute this address. So this is an example address. So as you can see here, it just consists of only 24 numbers, sorry 24 bits. So remaining 8 bits has been completely masked off by using this instruction not and not, which is nothing but NAND operation. And to mask, see, the first 8 bit has been masked by using an FF. So when I'm going to use the FF, that means whatever the data that has been present in this 8 bit, that will going to get 1 itself, and then by using a NOT operation, I'm just going to convert that into a zeros. That by that I'm just going to completely clear the first 8 bits of this instruction, and the remaining data will be whatever the data that will be used as a SWI number. So this is all about the SWI instruction. Thank you.